All right, hi everybody. So we're going to discuss our week 6 case study concept review. Um, there's really only one question that I really see errors with, and it's the question about what commonly form with renal calculi. So the question is asking if uric acid normally forms a urinary calculi. So uh, uric acid is something that is associated with the nervous system. It's something that dissolves into the blood and is processed via the kidney, but really it's just a waste product, and doesn't have all that much to do with kidney stone formation or renal calculi formation. What is really important for renal calculi formation is calcium oxalate. So these stones are made really when there's not enough citrate and there's too much calcium in the urine. Now, uric acid can play a role in the formation of kidney stones, but again, it's primarily this calcium and oxalate that are the two key substances here. Calcium is the main substance in something like 85% of all kidney stones. So that should really tell us what's going on there. Other substances like phosphorus can also be related. And then anything that really forms stones elsewhere in the body, if it has the potential to be filtered through the kidney, can also kind of cause this problem as well. Which again is why this is ultimately a question to make you think back. What is uric acid associated with? And so uric acid is so associated with these crystallized formation in gout, right? So there can be, again, a link between gout and kidney stones, but it's not something that is incredibly common because, again, it's that calcium and oxalate that are the two main substances behind that. Now looking again, the other question I'm going to bring up is a question about a laboratory sample. So which of the following would be affected by having a urine sample at room temperature for 3 hours? Our questions are bacterial content, color, specific gravity, and protein content. So we're going to start with the easy ones to rule out. Color. Color is something that will not change once the urine has left the body. Now, it's possible for certain substances to precipitate out of solution, meaning you can get like little crystals that kind of fall out of solution and reform into solids at the bottom of like a urine sample. That's pretty normal. That's not really going to change the color of the urine. Specific gravity will not change because remember, as we talked about all the way back in week 1 with our first introduction to Appendix 1 and specific gravity is really the relative density of a selected object compared to a reference value, and that reference value is water. Okay, so once the urine leaves the body, the content of that urine does not change. So specific gravity will not change. Okay, unless of course we add something to it, but that's not what's happening in this situation. The only thing happening to the urine is it sits at room temperature. Protein content is another answer. Protein content, again, is something that like we talked about all the way back in week 1, we don't really want to see much protein at all in the urine. Now, would leaving the urine out at room temperature for 3 hours lead to an increase in protein? No, because again, the protein would be leaving the body and entering the urine when the sample is collected. So the amount of protein that is in the sample is already in the sample before it is left at room temperature for 3 hours. The only real thing that would change in this type of situation is bacterial content. Typically, most bacteria that can infect humans can live perfectly fine or even thrive at room temperature, right? In fact, as bacteria starts to get into our body, our body temperature is one of our mechanisms of defense. We tend to sit right at the edge of a temperature where our nervous system can tolerate it, and the enzymes in our body work very effectively. If we go too much above our standard, 98 to 99 range, that's when we start to see problems. You start to have your fever, your enzymes start to work less effectively, and then, you start to hit that 106, 107 temperature, and that's when the nervous system and proteins in the body actually start to break down. And that's really extreme fevers, and typically are really only seen with things like viral infections, which don't have this same problem. Now, we raise our temperature in order to essentially do the same thing to bacteria, except bacteria really like to live at temperatures below our body. So if we get infected by a majority of bacteria, they're already a little bit out of, what you could think of as their comfort zone. They're already a little bit hot. So they're not working the most effective. Their enzymes are already slowed down. We add those couple extra degrees, though, and our immune system's really able to get the jump on them, start to increase replication, and get moving in terms of clearing the infection. So really, what we're going to see when this is left at room temperature is bacteria will have the ability to change. Because again, a lot of the bacteria that come out of a human are able to thrive at roughly room temperature. They'll be just fine at room. So that is everything for week 6. As always, if you have any questions, please don't hesitate to send me an email or ask in the Ask Your Instructor forum.